Welcome to Dangerous Prototypes. I'm Ian. Today we're going to talk about manufacturing open hardware, specifically the four main ways that we see open hardware being manufactured today. And then after that we'll go through the materials we send off to Seed Studio when we have a new project made. This is a real nuts and bolts presentation we've been giving all over the world for the last year. The first time was part of a discussion group at the Open Hardware Summit last year, and then we had the privilege to give it in London and Tokyo, and most recently at the Bay Area Maker Faire. I'm Ian from DangerousPrototypes.com. It may actually be the website surrounding this video, or maybe you're watching us somewhere else. What we do is open source hardware. That means all the files, documentations, pictures, all the stuff associated with our electronics projects. You can download that and remix it, reuse it in your own projects just about however you want. We don't actually do any manufacturing on our own. All of our stuff is made and sold by Seed Studio directly from China. We do very small batches of hardware. We're not making a ton of stuff. We used to do as low as 20, now generally we start with 100 and then work our way to 500 and 1,000 after that if a project's successful. I got my start as a maker posting how-tos at Instructables.com, and later I went on to work for DIY Life and the Hackaday blog. So the first thing we should talk about is why even bother manufacturing open source hardware? Well, we feel that manufacturing hardware brings together geeks who can etch their own circuit boards, solder things up, buy parts, and a huge community of software and other developers who have a lot to contribute to open source but can't necessarily build boards themselves. And manufacturing sort of bridges that gap between these two groups. And in order to have a thriving open source hardware community, we need to have people who can design web pages, write great documentation, and do stuff other than just raw hardware design. So the question is, how do you get started manufacturing that first project? We found about 4 basic ways that open hardware is being manufactured today. It varies in the level of involvement, how much stuff you have to do, and of course also the amount of money that you make. So the 4 we identified were licensing, full outsourcing, contract manufacturing, and DIY assembly. We'll talk about each in depth now. Licensing a project to a manufacturer is probably the easiest way to get it made. In licensing, maybe you have a popular design that's developed a community around it, and you're ready for the next step. You can submit it to a place like SparkFun or Adafruit, or maybe they even approach you and say, hey, we think this is cool, and we'd like to manufacture it. The licensor takes all the risk. They'll usually redesign your hardware to fit their standard parts list. They'll also front the cash and make the first inventory purchase. They'll sell everything from their website. They take care of just about everything. You, as the project creator, generally get to support their users and get, in general, from the 4 or 5 offers we've had to license different projects, you get generally 10% of the profit that the manufacturer makes by selling your widget. The downside of this is you don't have a lot of control over the quality of the brand. There's very few options to expand because only the absolute best projects, the top projects that already have an existing community that seem like they could be profitable for someone to take on, those are the only ones that are going to be picked up for a licensing deal. However, you can manage. Licensing is certainly easier than any other method. And if you're just doing a project for fun and you'd like copies of it to be out there, if you can get a licensing deal, it may be the perfect solution for you. Fulfillment is what Dangerous Prototypes does with Seed Studio. When we have a new design, we send off a list of materials and the parts files, and they give us a quote for 100, 500, and 1,000. We decide how many to stock in their store, and they take care of the manufacturing and sell it from their web shop. Here we have a lot more responsibilities than we would under a licensing scheme. We support users. We're also in charge of inventory management, not just making sure we keep things in stock, but making sure we don't have widgets rotting in a warehouse in China somewhere. We also take care of wholesale. We arrange our own wholesale orders with wholesalers all around the world. We really like this arrangement because we get to concentrate on design, which is what we like best. Seed Studio takes care of all the boring stuff like manufacturing, putting things in boxes, making sure they get to the post office, and handling returns. Contract manufacturing is how most things in the world get made. Xboxes, iPhones, all these kind of things are built by professional assembly houses that do nothing but build boards. Here, you run almost the entire business. The only part you're sending out is the actual manufacturing itself. Depending on the assembly house, you may need to send a box with parts and circuit boards, and then they actually take care of assembling the boards. Some of them may be able to get that stuff for you. With contract manufacturing, you're doing just about everything. You're receiving inventory and keeping it in stock. You're running a website where you sell things. You also do fulfillment, which means putting things in boxes, putting stamps on them, taking them to the post office. Also handle returns and wholesale. Contract manufacturing is a great way to go if you want to sell things from your own website, but don't want the hassle of manufacturing things on your own. Next up is DIY assembly. This is where you handle absolutely every part of the manufacturing and sales process. We see this breakdown into two basic categories. The first is small volume. This works for kits. An example of this is the Nanode. It's a small Arduino board with an Ethernet section attached. Ken kits these up by hand and then ships them out all over the world. Another example is actually assembling small volumes of hardware yourself. Our friend Brian at Tejo Labs assembles small volumes of his surface mount projects himself and then ships out the completed boards. For the big fish, there's the pick and place machine. This is an awesome robot with big reels of parts and an arm that places the components on the circuit board. That way they're ready to run through an oven and be soldered all at once. This is the fabled garage assembly line. And while it's fantastic if you have enough volume to support it, we find most small hardware shops actually regret going the pick and place route. You can buy a pick and place machine, but then you'll spend the next 6 months or so learning how to use it and getting it to work consistently. Every time we give this presentation, we meet several people afterwards who say, you know, I did that. I thought I could set up a garage assembly line and build my own boards and absorb all that profit. But in the end, I spent 6 months learning how to use the machine and didn't even get it work satisfactorily at the end. So they end up going a contract manufacturing or fulfillment route. That 6 months is valuable time you can use to develop your project, new projects, and you lose that learning to work with the pick and place machine. It really is a full-time job. In contrast to that, we've also heard the flip side of the story, which is that people started trying to build their own stuff with a pick and place machine, and then eventually ended up doing that full time because they found it was more profitable to work on other people's boards full time than use it occasionally to build their own stuff. So our advice on the pick and place machine is, unless you have the volume of an Adafruit or a SparkFun and can run it several hours a day, just avoid it. So next we'll move on to the second part of the presentation, which is looking at the actual materials we send to Seed Studio when we start a new project. This isn't going to be the same for all the different methods of manufacturing hardware, but these are the basic nuts and bolts of what goes into producing a new product. The board files in Gerbers contain the actual circuit board for the project, as well as showing where each part goes and its correct orientation. We use CADsoft Eagle for our boards. It's free but not open source. However, a huge chunk of the open hardware community uses it, so you find a ton of footprints and a ton of existing projects already in Eagle. Gerber files are a standard format that any circuit board manufacturer can use to build circuit boards. Just about anywhere in the world, if you find a board manufacturer, you can send them Gerbers and they can return you a PCB. If CADsoft Eagle files are like a Word document where you can still change things, then Gerber files are like a PDF where things are static, but they look the same wherever they're displayed. For each project we also send a part list or a bill of materials, often shortened to BOM. This is all the stuff that's actually stuck to the board, including the values and any special information about it. We usually submit it as a spreadsheet. You can see an example here. It lists the part number, a short description, the value, the package, which means size, and how many go on the board. For common stuff, we usually just specify the value, the voltage, and the size. So that's things like capacitors, resistors, crystals. We can just specify a 16 megahertz crystal and the package we need. For more specific stuff, like transistors or microcontrollers, we actually specify a complete part number. Dangerous Prototypes maintains a master part list on our wiki, and we try to design all of our projects around these parts. It's what we stock in the workshop, so it's cheaper to use. Also, these are things we're fairly certain that they can find local substitutes for in China at reduced prices. You also need to send the firmware, software, or anything that needs to be programmed into a chip on your project. This could be a hex file for a microcontroller, or it could be a JTAG programming file for a CPLD or field programmable gate array. We also need to send programming instructions and any utilities that are actually used to program the firmware into the chip. So we have to send complete documentation to Seed explaining how they actually get the stuff into the chip and get it ready to ship. A test plan is super important. This is the procedure used to determine whether something is working before it's shipped out to a customer. Nobody likes getting a dead device and then waiting for a replacement to ship. And the test plan is what's going to help make sure that the customer gets working parts every time. Here you can see an example of the Bus Pirate self-test. By bridging 2 pins, the Bus Pirate can test its own hardware and be relatively certain that everything is stuck to the board properly and working. Think about your test plan early, preferably during the design phase. It's really hard to bring out test pins or build a test rig if you haven't thought about it when you started designing. It may be very difficult later to get things out to a convenient place for an easy and quick automated test. Clear back in the beginning when we started working with Seed, they would build our prototypes from just the files and the description alone, but we had lots of problems making sure everything worked right. Now we start sending prototypes every time and it goes a lot smoother. Copy is the pictures and text that actually sell your project to people. There's a whole industry built around writing advertising copy. We're not particularly good at it. We try to give lots of facts, a realistic feature list saying what exactly this device can do. We consulted with a few copywriters and one actually suggested we make an emotional appeal. Well, it's not really clear to us how you make the bus pirate appeal to your emotions. So instead, we try to sell with facts. We try to give clearly stated features and then links to all the manuals and documentation somebody would need to decide if our project's actually going to do what they want and be helpful in their own project. We also try to take Adafruit's suggestion and have good action picture of our hardware whenever possible. That means showing it in use, showing what it can do, showing it doing whatever it does. So that's our overview of the 4 manufacturing processes commonly used to make open source hardware today. Licensing, which means someone else makes your widget and you're just providing support and doing the bare minimum. Fulfillment, where you're actually starting to take charge of stock and inventory, but someone else takes care of manufacturing, selling things, and running a website. Contract manufacturing, where you're taking care of everything except the assembly part itself. And finally, DIY assembly, where you're doing absolutely everything yourself, including assembly. Then we gave a short overview of the things we send to Seed Studio for a new project. These aren't the same as used for every manufacturing process, but these are fairly common things. That includes design files, including our Eagle files and our Gerbers, a prototype to base their prototype off of, a part list, or the things that get stuck to the board, programming files and software, anything that gets put into chips on your project, and instructions for doing that, a test plan that says how to make sure the project is working when it leaves your workshop, and finally copy, the text and advertising materials used to sell a device. Hopefully you can take some of these things home and use them when you design your own projects. We've given this presentation a lot, so we're going to move to something new for future conferences, but we're still available to talk about open hardware manufacturing if you have an event or something you'd like us to attend. Thanks for watching. We'll be back next week with a new project.